Explain resistance. To understand resistance, let's consider a simple physical analogy. Let's suppose that a man is trying to push a box on an inclined plane. We know that the man has to apply a certain force to move the box. As the frictional force is resisting its movement, so we can say that friction is providing resistance to the box's motion. Now let's understand electrical resistance. Consider two different bulbs connected to batteries, providing the same voltage, say V. These bulbs have the same voltage across them. Now we see that bulb 1 has a brighter glow than bulb 2, as the current flowing through them is different. Thus we can say that bulb 1 has a lower resistance, as it gives a higher current for a given voltage, whereas bulb 2 has a higher resistance, as it gives a smaller current for the same voltage. Hence, resistance is an inherent property of a substance due to which it opposes or restricts the current flow. In electrical circuits, resistance is represented by the symbol. The unit of resistance is ohm, and its symbol is the Greek capital letter omega. It is named after the early 19th century German physicist Georg Simon Ohm. Thus, resistance is a measure of how much an object opposes the passage of electrons or current flow. The resistance of a conductor basically depends upon the material it is made up of and its shape. Now let's take a conductor of length L and cross-sectional area A. Assuming that the conductor is made up of only one material, the resistance will be inversely proportional to its cross-sectional area A and directly proportional to its length L. Thus, resistance is directly proportional to L by A. Mathematically, electrical resistance is expressed as R, where R is the resistance of the conductor in ohms, L the length of the conductor in meters, A the cross-sectional area of the conductor in meter square, and rho the resistivity in meter ohm. Note that although resistance is temperature dependent, this formula can be used to calculate the resistance of a wire of given geometry at a given temperature. The related terms are